Got it. Okay, so I hope everyone is fine with electrochemistry. Yes or no? Please tell me, guys. Krishna, Akshay, Atif, Hamza, Hiba.
Yes, sir.
Yes. Okay, fine. Because what I saw is that, like, if I will tell you the percentages, then almost everyone is having solution chapter, and then almost everyone is having haloalkane halorine chapter. Okay. Now the next most common chapter is alcohol, phenols, and ethers that I have completed. So in that way, I'm fine. But the next, like almost 70% of the students, they are going to have electrochemistry in their examination. So I think it's good, be good that I will teach electrochemistry. And if I look at your particular batch here, those who have filled the form till now, that is C batch. So in C, so we have electrochemistry for everyone apart from, okay, fine, DNF. Okay, DNF block has been started there. Okay, Hiba. So electrochemistry is there for everyone except the people who are in Riaz. Okay, so I think Akshay, you will know that later on, like maybe tomorrow or day after tomorrow, that electrochemistry will also be there. So alcohol, phenol, ether आपको खत्म हुआ है ये अक्षय या फिर नहीं खत्म हुआ है अभी? Alcohol, phenols and ethers.
Ongoing.
Ongoing. कहाँ पे मतलब कहाँ तक हुआ कुछ पता है? याद है?
No, sir. So I think she won't come for a week. Like she'll come from next week or something.
Oh,
The lab assistant told that she won't be able to come for a week.
Okay, fine.
Not sure. Yeah.
Not sure. Okay, no problem. But I think electrochemistry will be there. I think you have some exam on October also. You may ask like other sections. You may have multiple teachers, right, Akshay?
No, sir.
One teacher only?
Yes, sir.
And there is another teacher for the girls section, or it's the
Yes.
same?
Different.
Okay, different. So you can ask Mansi maybe. I mean, if her teacher is there, right? I think you guys attend some more classes together, right?
Only maths.
Only maths. Okay. So if you can, you like try to know, है ना, कि कौन सा
Okay.
chapter है. Most probably it is going to be electrochemistry only. That's what the other girls have also told me. Okay, fine. Now,
No.
electrochemistry. Now, this chapter is going to be a bit different from the organic chemistry that we have learned till now. Aldehyde, I mean, some of aldehyde ketones, but mainly we have done haloalkane, halorine, and alcohol, phenols, and ethers. This is related to physical chemistry, and here we'll be touching the topics that is more closer to the physics part. Now, chemistry is one of the subjects that is in center. Actually, you have physics, we have chemistry, we have biology. So chemistry is the only subject in which you have to learn things about biology also, and we have some things about the physics also. Okay, so it is also known as the central science. We apply the physical formulas. I mean, we apply the physical law to the biological system in order to understand the biology of everything. So that is why you will have physical chemistry also, and we have biochemistry also. So in that sense, it is, for some people it is the good of both world, but for some people it is the worst of both world. कि मतलब सभी कुछ पढ़ना ही पड़ जा रहा है chemistry में. Okay, but it is fun. If you know chemistry, that means you will get some main principles from biology also, some main principles from physics also. Okay. Now, when we talk about the physical reality, there are mainly I divide the physical reality into main three parts, but you can also divide it into some other parts. We'll have mass, right? Our physical reality is made up of mass. It is also made up of energy. Okay, and there is also time here, right? We cannot see time, but time is always passing on. So there is also time. Physical reality is also made up of time. Now, and all of this encompass, this mass energy, they are encompassed in a particular space. Okay, so there is space and time. In space, we have mass and energy. But some may argue that mass and energy, they are also related. They are the one and only same, because E is equal to mc square. We can interconvert mass and energy. But I would like to think that mass and energy are different, because in macroscopic scale and the reality that we live in, we tell them apart. Like mass and energy, we don't batch them as same thing. So we have energy. Now, in this chapter, we are talking about energy. We are going to learn about energy. And whenever we learn about energy, we learn one of the two things. We either learn the transfer of energy, or else we learn the transformation of energy. Transfer of energy is talking about the flow of energy, and that you have learned in both chemistry and physics. That is the chapter thermodynamics. When we talk about the transformation of energy, then we convert the potential energy into kinetic energy and vice versa, right? When we have water falling down from some dam that is having potential energy, that water is having potential energy, then it is getting converted to kinetic energy. Now that kinetic energy then getting converted to mechanical energy in the form of wind turbine. That mechanical energy is getting transformed into what? Into electrical energy, right? So we have transformations of energy, or we have transfer of energy. Now, in this particular chapter, okay, one more thing that is very important. There is something which is known as spontaneous. Okay, so Akshay, what do you understand by spontaneous? Like when I say spontaneous, what comes to your head? Something that happens quickly? Is it something else? Akshay, Krishna?
Yes, sir.
Something that happens quickly.
Yes, sir.
Okay, fine. Akshay, what about you?
Yes, sir.
What's your same thing?
Spontaneous.
Okay. Atif, spontaneous.
Instant.
What do you? Okay, Akshay, tell me. You're saying something, Akshay?
No.
Okay. Yes, Atif, spontaneous.
Yes, sir, same thing, sir. Something that happens quickly.
Okay, fine. So let us suppose that you picked a pen and you lifted your pen up from the table. Is that spontaneous? That movement of pen, is that spontaneous? If you lifted it quickly, you're lifting pen up from the table. Is that a spontaneous thing that is happening? Like, is that pen?
No.
No, but that is happening quickly, right? What's the difference? Yes, Hamza. Okay. What's the difference, Akshay? That's happening quickly, right? Yes or no?
Yes, but
But it is not spontaneous, right?
we can also take it slowly. It's like slow, but something which happens immediately without like,
Yeah. Okay, right. Hamza is fine. You're going in the right direction, by the way. Krishna, can you add something up? Maybe you are getting towards the right answer. Spontaneous. Something happens. Seeing quickly. Now, for example, okay. Let us say, for example, rusting of iron. Is that spontaneous? Yes or no? Like if you keep the iron and don't do anything on it, you just like if there is water falling and all. So rusting of iron, that's not spontaneous, Akshay? Atif, what do you think? Rusting of iron, spontaneous, not spontaneous?
Not spontaneous.
Not spontaneous? Yes, Heba remembers. Okay, fine. Heba and Hamza, they remember actually. See, spontaneous has nothing to do with time. Okay, spontaneous has nothing to do with time. If you remember, acha, take it. Spontaneous reaction. Which chapter did you remember spontaneous? This word is spontaneous from? In chemistry, you must have learned this in 11th standard. No, which chapter was that? Which chapter was that in 11th standard? Very good, correct. Thermodynamics, right? Akshay, Hamza, Heba, all of you remember Krishna? It was
Yes, sir.
thermodynamics. Okay, fine. In thermodynamics, did we ever study about time? Like,
No, sir.
was time there in any of the equations that we did?
No.
No, right? Akshay, Atif, time was not there, correct?
Yes, sir.
Time was not there. And we are going to learn time in the chemical kinetics chapter. Okay. How, like, what is the speed of reaction, the rates of reaction that you have also learned in haloalkane, halorine, and alcohols? Like, how fast the reaction is going to happen? That is dealt with chemical kinetics. Now, spontaneous means anything which happens on its own. Okay. For example, like me on its own, in the sense that human does not have to put in any effort. Okay, like कुछ भी अपने आप तो नहीं होता है. I mean, there is some kind of force which is acting on it, and then only something happens. But driving force should be there. But I'm not talking about that driving force. I'm saying that if there is something which is happening without the intervention of humans are not interfering in anything. Humans are not putting in energy in order to in order for that thing to happen. For example, if I have a pen that is falling up and up from the up, then it is not needing any kind of energy from humans. That is spontaneous. But if I have to lift something up, I have to give in energy. That means it is not spontaneous. Okay. So spontaneous, it has nothing to do with, even though it sounds something like which is going to happen quickly, but it is not a necessary condition. Okay, for example, rusting of iron is a very good example. That is very slow, but it happens on its own. Okay, it happens on its own. Even, for that matter, diamond, it slowly it changes its carbon have two allotropes, right? Diamond and carbon, that is graphite. So diamond can change to graphite. Okay, as iron rust, diamond can also change its form to graphite, and it is a spontaneous reaction. Okay, from diamond to graphite. Okay, it is a spontaneous reaction. It will happen on its own. It does not require any human intervention. But are humans fool that they buy so much of jewelry that is so costly, jewelry that is made up of diamond? No, because that is very slow. That change is going to happen, and it is very, very, very slow. Okay, so from diamond to graphite, it is slow, but it is spontaneous. Eventually, it is going to happen. Fine. Now, whenever we have this type of spontaneous, not reaction, but spontaneous change, I should say, for example, water falling down from the dam, that is spontaneous because it has potential energy. It does not require any human energy. If anything, any spontaneous change is there, then we can use that spontaneous change and not create energy, rather we can transform that energy in a useful sense. For example, water is falling down, that is no use for us other than just going there and enjoying that particular scenery. But in order to get that energy, we have to convert it, we have to transform it into electrical energy, and then we can use it furthermore, right? So we are going to change that into useful kind of energy. Now here what we are going to do, here we are not having any dams, but rather there are some spontaneous reactions. Now those spontaneous reactions are also chain. So chemists, they thought that, chemists and physicists, everything gets mixed up back in the time and when you further advance to your studies. Okay, so a spontaneous reaction can be used in order to generate electricity. Now this was their thought. Okay, so in this chapter, what we are going to do, we have two forms of energy, that is electrical energy and we have chemical energy. We are going to transform electrical energy to chemical energy. Okay, that means there will be some non-spontaneous reaction for which we will give electricity. We will give the energy in the form of electricity and do that changes. And there will be some spontaneous reaction which will be used for the formation of electrical energy. Okay, formation of electrical energy. If you think about it, we have pumps which lift water up, right? Which lift water up. And then we have generators that take the turbine, that mechanical energy, and they generate the electricity by falling of water. So the same thing is happening here, right? What we are doing, we are using some electrical energy to bring about some chemical change. That means some non-spontaneous reaction. That means we are pumping the water up in this direction. And this is the work of the generator. Here we are going from chemical energy to electrical energy. We are using the spontaneous reaction in order to generate some kind of electricity. Okay, Chali. First of all, write what is electrochemistry. So please write this with me. Electrochemistry is the study of electrochemistry is study of production of electricity from energy which is released during a spontaneous chemical reaction. A spontaneous chemical reaction. And It is the use of electricity, or rather electrical energy लिख लीजिए आप, electrical energy to bring about non-spontaneous chemical transformation. Okay, so we have spontaneous reaction. This is going to release energy. And we are going to convert this energy to electricity. There will be, and we are going to use electricity and we will use electricity on non-spontaneous reaction and bring out some chemical reaction. No, we will do that chemical reaction. Done, guys? Yes or no, please tell me. I think at least the first statement must be done. Now write some important terms. Okay, now some of these terms all of you would have heard this, but if you don't remember, oxidation.
Can you scroll up?
Yeah, sure. Oxidation, it is loss of electron, or we can say gain in oxidation state. So for example, we have zinc, and zinc is losing 2 electrons. It forms zinc 2 plus, right? And we will get 2 electrons, right? We will get 2 electrons. So if you see here, zinc has 0 oxidation state, and here it has 2 positive. That means it has lost electron and it has gained some oxidation state. The next one is reduction. Now, I want you guys to just like write it on your own also, okay? Don't wait for me to write each and everything, because I know that you're going to write here gain of electron or loss or decrease, we can say, no? Decrease in oxidation state. So for example, we have copper 2 plus. If it gains electron, that I have added 2 electrons, it consumed 2 electrons and got copper solid. Now it has 2 plus, so 0 yahan pe ho chuka hai, right? So this is going to be reduction. After this, you will write electrolyte. Third term. Electrolyte. What is electrolyte? What is electrolyte? Compounds that dissociate in the compounds that dissociate to ions, right? When we have them in liquid phase or we have them in aqueous phase. Please write compounds that dissociate to form ions when in liquid phase or aqueous phase. Okay, I hope you understand liquid phase and aqueous phase are different. If I have, let us say, for example, sodium, and if I will melt it, it will become like sodium liquid. In that also will have electrolytes. Okay, those also will contain Na positive. And if I will add water, then also it is going to have Na positive. Okay. For example, NaCl also is that one example. If I will melt it, I will have Na plus and Cl negative. And if I will add water to NaCl, it is also going to have Na plus and Cl negative. Right. The fourth one. Electrode. Electrode is the surface at which oxidation or reduction occurs. Fifth one is redox reaction. It is an oxidation reduction reaction, a reaction in which both oxidation and reduction is taking place, not of the same species, but of different species. For example, if I have, let us say for this one, zinc plus copper 2 plus is going to give you zinc 2 positive and copper. Okay, so we can say that zinc is getting oxidized and copper is getting reduced here. Please write this down. Done, everyone? Yes, no, please tell me. All of you done?
Done, sir.
Okay. Now, I'm going to explain how we can think about electrochemistry and how we got the electrochemical cell. If you have seen the electrochemical cell in your chemistry notebook, it is quite big and a bit scary, but we will work it out and we will see that how we came up to that particular complicated structure. Okay, so we'll start with a very simple example that we have NaCl, right? And how is NaCl formed? We have Na. It is going to give an electron to Cl. This Na is going to get converted to Na plus, and this Cl is going to get converted into Cl negative, right? So this is something that happens. We have Na and we have Cl. Na gives electrons to Cl and it is getting converted to Na plus and Cl negative, and we are forming NaCl. So chemists said that, wait a second. What if, let us just imagine, okay, so all of these things are not true, but you can imagine it like this, that if I have Na and if I have Cl here, then obviously these two are not talking. These two are not talking. What if I add a wire between them? If I will add a wire between them, this Na will have a tendency to lose electron and it will give electrons to chlorine. And once it gives electron to chlorine, this chlorine will be getting converted to Cl negative. Now that is a spontaneous reaction. That means we know that Na, it loses electrons, and Cl, it gains electron. Both of these things are spontaneous. So if we attach a wire to them, then what is going to happen? In this wire, we can flow electrons. So this will be the flow of electrons, and this will be the flow of electricity, right? Now, if I will have a bulb here, then what is going to happen? This is going to glow for once, but after that it will stop because there is only one time travel of electron. Can all of you, are you guys with me? Yes or no, please tell me. Atif, Akshay, Hamza, Hiba, and Krishna.
Yes, sir.
Yes, sir.
Right? Okay, fine. Now, in order to sustain this kind of electricity, we had to do something else. Okay. So you said that obviously this is not going to be very sustainable. You will see some light up bulbs for once, but it will stop glowing after a while. It will stop glowing after a while. They said, okay, fine. Let us see some other examples. They said, okay, we have seen that if I have some solution like this, Okay, this is CuSO4. And if I dip a zinc rod here, we see that what happens, the zinc slowly displaces the copper. We have zinc and CuSO4, and this zinc displaces the copper and it forms zinc 2 positive. Sorry, not zinc 2 positive, rather we can just write ZnSO4 plus Cu. You must have seen this reaction in 9th or 10th standard, right? Yes or no, please tell me. When we dip zinc into copper sulfate solution, the blue run, the blue color disappears, right?
Yes, sir.
Right. Okay, fine. Okay, fine. Here also what is happening actually, if I see, here we have, I can write zinc as zinc. I can write copper as Cu2 positive. I write Cu2 positive, and I can write SO4 as SO4 2 negative. And here I can write, it is getting converted to zinc 2 positive plus copper plus SO4 2 negative. Right? SO4 2 negative. Now, since SO4 2 negative is similar here, I can just cancel it. And I will say that what is happening here is zinc plus Cu2 positive. It is going to give me zinc 2 plus Cu. Now, what I see here is zinc is losing 2 electrons and copper is 2 plus 2 neutral. How it will have 2 plus 2 neutral? Either unless and until it gain electron. It is gaining electron. How many electron? 2 electron. Now, where are these 2 electrons coming from? These 2 electrons are coming from this zinc only. That means there is a transfer of electron that is happening here. There is a transfer of electron that is happening here. But again, the problem is same, that if I join something like this, then also it is going to have some glow, and there will be lighting up of bulb for a while, but again it is going to stop once the reaction stops. Now what they said, okay, fine, what if we separate these two things? Okay, so this came up with this particular setup. Let me draw this here. Okay. Now, here they had put zinc and ZnSO4. Here we have ZnSO4. Okay, I think I should remove these parts because I may need to write something here. And here we have CuSO4. In the zinc compartment, they dipped a zinc rod. And here they dipped a copper rod. Okay, here they have dipped a copper rod. And after that, they connected both of these things to a wire. Let's see, it's not going acting well. Okay, now this is wire which is connecting. This is zinc rod. And this is copper rod. Now, what is happening here in this reaction? Tell me. Zinc is losing electron. Yes or no? Please tell me, guys. What is zinc doing? Zinc is losing electrons. Very good. Now, zinc, and we have zinc here. That means in the zinc rod. Here we have Zn2 positive already. Zinc SO4 will have Zn2 positive. So this cannot lose electron. What will lose electron? This zinc is going to lose electron. Now, zinc will lose electron and it will get transformed to Zn2 positive, right? And as soon as zinc will get to Zn2 positive, Zn2 positive is going to solution. and there will be 2 electrons which is left. Yes or no, please guys tell me. Correct? Now these 2 electrons which will be in the rod, they will move like this. They will move, they will move, they will move, they will move, and they will reach the copper compartment. And in the copper compartment, they will meet 3 people. Electrons meet, what they will meet? They will meet copper rod. Next, they are going to meet Cu2 plus in solution because rod is dipped in the solution. And they will also meet SO4 2 negative in the solution, which is dipped in the solution, right? They're going to meet these 3 people. Now, what do you think? Which is going to react with this 2 electrons? Now, if I see, I can directly say that SO4 2 negative is not going to react because SO4 2 negative is electrically negatively charged. And this is also negatively charged electrons. So they will repel each other. Fine. Then I will ask whether copper will eat up the 2 electrons. Then copper will say, no, I'm a metal. My tendency is to lose electron, not to gain electron. So I'll say, okay, fine, that's fine. So copper is also done. Now, if I see this copper 2 plus, now this copper 2 plus is not a metal, it is an ion. You have to understand the difference between copper and copper 2 plus. Copper is a metal, but copper 2 plus is an ion, and 2 plus is an ion. We have the 2 plus charge, so this will be getting attracted. The 2 electron will get attracted, it will react with copper 2 plus. What is going to happen then? Copper 2 plus 2 electrons, it is getting converted to copper solid. Now, where will this copper go? This copper will go to rod. We saw another reaction here in the zinc compartment. We had zinc. It got converted to zinc 2 positive plus 2 electron. Now, this zinc was from rod. Zinc 2 plus went to solution. And 2 electron, it went to rod. Right? Cu2 plus is getting from solution. We are getting Cu2 plus from solution. 2 electrons we are getting from rod. And the copper is getting to the rod. All of you understood these 2? Yes or no? Please tell me what is happening and where it is happening. Yes or no, guys? Please tell me. Atif, Akshay, Hamza, Hiba, and Krishna.
Yes, sir.
Yes, sir.
Okay. Now, this is the most important thing that you have to have clarity about. That first of all, what are the things reacting? Where are they coming from? From the rod, from the solution, or where are they going? There are only 2 things. Either they will be coming from the rod or they will be going to the rod. Okay. Fine. Now, let us see what is happening. In the zinc compartment, this zinc rod is getting converted to zinc 2 positive. The zinc rod is getting converted to zinc 2 positive. That means zinc metal from the rod, it is getting converted to solution. It is going down in the solution. Zinc rod metal mass, it is going down to the solution. That means the mass of zinc rod is decreasing. Yes or no? Mass of zinc rod will decrease with time. Is that right? Yes or no? Please tell me, guys.
Yes, sir.
And since it is getting converted to zinc 2 plus, its concentration will increase. Yes or no, guys? Please tell me.
Yes.
Zinc 2 positive, concentration will increase. And can I say that if its concentration is increasing, this compartment is getting slowly positively charged? Here we have more positive ions. Yes or no? Here we'll have more positive ions. Correct? Atif, Akshay, Hamza, Hiba, and Krishna. Please tell me yes or no. Hiba, आपको आ रहा है?
Yes, sir.
हिबा, आपको समझ में आ रहा है? हिबा? Yes. Okay, fine. Very good. Now let us look at what is happening in the copper compartment. In the copper compartment, if you see the copper 2 plus from the solution, it is getting converted to copper solid. It is going to the rod. That means the mass of copper is increasing. Yes or no? Mass of copper rod is going to increase. And here we have Cu2 plus ions. These ions will decrease. Yes or no, guys? Please tell me, guys.
Yes,
Cu2
sir.
plus ions are decreasing. So what charge will be there? What can I say about this compartment's charge? It will turn negative. Yes or no? Because positive is decreasing. Positive SO4 2 negative. देखिए starting में आपके पास 10 Cu2 plus था और you had 10 SO4 2 negative. And now Cu2 plus has got onto, let us say, 3 ions. And SO4 2 negative is going to be 10 only, na? So we can say that it is getting negatively charged. Yes or no, guys? Please tell me.
Yes,
Yes,
sir.
sir.
Yes, sir.
Right? Okay. Now the problem starts. I mean, everything was fine till now, but as soon as you see this positive charge and negative charge, you should think that, okay, fine, wait a second. Okay, fine, wait a second. Why are the electrons going this way? If it is getting negatively charged, what is going to happen after a while? This is going to happen after a while only, because initially both of them will be neutral. But as the reaction will go on, as the cell will start working, as the cell is working, zinc is getting converted to zinc 2 positive. Electrons are going from the rod. Electrons are going from the rod to the wire, then again to the copper rod, and then in the copper rod, Cu2 plus is getting converted to copper, and we are getting positive charge in the zinc compartment, negative charge in the copper compartment. Then the electron will say, why I am going there? I should stay here only. The zinc compartment with its positive charge, it will attract the electron and it will stop the flow of electron. What it is going to do? It is going to stop the flow of electron. Now the bulb has stopped blinking. It has stopped glowing. Now again, the scientists would come. They will see what is happening. Now, actually, what I told you before, that positive and negative charges, scientists came up to know after analyzing this particular cell. Okay, fine. Zinc 2 positive's concentration has increased. That is why it is getting positive charge. The copper 2 plus is decreasing. The concentration is decreasing. That is why it is getting negatively charged. Now, if I have something that is going to neutralize this zinc compartment and the copper compartment, if I am having something which is going to neutralize the zinc compartment and the copper compartment, my work is done. We can have electricity for a bit more longer time until unless all the mass of zinc rod has been converted to zinc to positive, right? Till then we can have the reaction at least. So they said, okay, fine. Then we will add something, and they added something which is known as salt bridge. Now, what is the work of salt bridge? You will see here only, then write later on. But see, actually, what is happening? They have some inverted U type of thing. Okay. Now, in this, they have Cl negative ions and K plus ions. Ab ions to nahi rakhenge, but you know that KCl is a salt, right? So they add KCl salt. Now, as the zinc 2 positive concentration will increase, as soon as the zinc compartment will become more and more positive, the Cl negative will come here. It will neutralize the zinc compartment. As the copper 2 plus compartment is getting more and more negative, the K plus will come and it will neutralize this compartment. And once it is neutralized, the electron, now the zinc compartment cannot hold the electrons, right? Because it is neutral. So the electron will flow as it was flowing earlier. Is this clear? Yes or no? Please tell me, guys, all of these things, what is happening, what is not happening?
Yes.
Right? Okay, fine. Now you will write here electrochemical cell. Please write electrochemical cell. Okay, right? The cell in which spontaneous redox reaction occurs due to spontaneous reaction. Redox reactions occur due to which chemical energy is converted to electrical energy is called electrochemical cell. Okay, electrochemical cell, it has also one other name that is known as galvanic cell. And after that, you are going to draw a picture. So here we will have zinc SO4 and here we'll have CuSO4. Okay, so draw this figure, write this, then we'll write some remarks, whatever we have done till now. Okay. Okay, one more thing. This arrow here, no? This arrow. This is talking about the flow of electron. Done everyone? Yes or no? Please tell me.
Done, sir.
Okay. Now, so we'll see what is happening in the zinc compartment, right? At zinc compartment. First thing is that we saw that there is a reaction happening in which zinc is getting converted to zinc 2 positive and 2 electron. This zinc is coming from rod. This zinc 2 plus is going to solution and this is going to rod. Okay, that means first thing that we can say that it is what is oxidation. This is oxidation. Okay, and wherever you have oxidation, that compartment will be known as the anode. That compartment will be known as the anode. And since this rod is getting this 2 negative, right, electrons, that means that rod will be negatively charged. So the polarity will be what? Polarity is going to be negative. Okay. Now let us look at what is happening. Now you please start thinking about the copper compartment. है? Copper compartment में क्या हो रहा होगा? है? वो सारे reactions क्या हम लिखने जा रहे हैं उनके बारे में आप प्लीज थोड़ा assume करने लगिए तभी आप लोगों को आसानी होगी याद रखने में. At copper compartment. Here we saw a reaction in which copper 2 plus from solution was eating the 2 electrons that was coming from rod, and this was getting deposited as copper. So this is obviously it is gain of electron. It is going to be reduction. Okay, and since it is reduction, it is going to be cathode. The compartment where the reduction happens, it is known as cathode. And if I look at the polarity, Now, since the electrons are attracted towards this pole, this will be positively charged. Okay, and that is why we have this zinc here, we have this negative, as you can see. And here we have this positive. Okay. So you write these two things. And also one more thing, like this is not the only one electrochemical cell which we are going to study. That is why from now on, what we are going to say, that this is going to be anode compartment, and we are going to refer wherever the reduction is happening as the cathode compartment, not as copper or zinc compartment. Okay. So this first time was just for your family, like you're familiar with zinc and copper right now. So zinc and copper likh diya. But after this, we are going to refer wherever the oxidation is happening as anode, wherever the reduction is happening as cathode. Is that clear? Yes or no? Please tell me, guys.
Yes, sir.
Yes.
Okay. Let me know if you're done. And we will move on and then write the cell reaction. This is going to rod also, right? Please let me know when you're done.
Done, sir.
Right, next, cell reaction. So we have two different, we also say this is the anode half cell or cathode half cell, because we have this anode half reaction and cathode half reaction, oxidation half reaction, reduction half reaction. These words are used interchangeably. So what happens in cell reaction, actually, this is whole one cell, no? This is one cell completely, which has two reactions happening. So one is happening at the anode. So we'll write anode first of all. In anode, what is happening? In anode, we saw that we had zinc, and this is getting converted to zinc 2 positive and 2 electrons. And then we have cathode. In the cathode, we saw that we had copper 2 positive plus 2 electron. And it was getting converted to copper solid. Now, when we are going to add these two reactions, we are going to get the complete cell reaction. These are half cell reaction, anode half cell reaction, cathode half cell reaction. We can say that this 2 electron and this 2 electron can get cancelled, and we will just write that we had zinc plus Cu2 positive, and we got zinc 2 positive plus copper solid. Okay, so this is the cell reaction. After this, we are going to write some remarks. Please write remarks. Number 1, an indirect redox reaction. Takes place in electrochemical cell. What is an indirect redox reaction? A redox reaction in which oxidation and reduction, both of them, they will occur in different containers or compartments. It is known as indirect redox reaction. Please write the redox reaction in which oxidation and reduction occurs in different compartments, in different containers. You can also write. Different containers is called indirect redox reaction. Right, next point. When metal is dipped in solution of its own ion, then the metal rod requires either positive or negative charge with respect to the solution. Due to, there are two reasons. See, some metals.
Can you scroll up?
Achha, wait a second. फर्स्ट पॉइंट नहीं लिखा आपने, फर्स्ट पॉइंट लिख लिया आपने आतिफ?
Yes.
Okay. We have metal from rod. Okay. And if it gets converted to Mn positive, whatever its valency is N positive, and it gives you 2 electron. For example, अगर यहाँ पे sodium होता, तो it will be sodium 1 positive and 1 electron. If it was, let us say magnesium, it will be magnesium 2 positive and 2 electrons, zinc 2 positive to 2 electrons, right? So Mn positive and 2 electrons. So this will be going to solution, and this will be going to rod. And this will give that rod a negative charge. Negative charge on rod. Similarly, some metals, they have a tendency in which N positive will eat N electrons to form atom M. So this is coming from solution. Okay, and this N electron is coming from rod. And this is going to rod. And this type of reaction is going to give a positive charge on rod. Positive charge on rod.
So in the above reaction also it should be N electrons, right?
Sorry. Sorry. Yeah, N electrons. My bad. Done, guys. Yes or no? Please tell me.
Done, sir.
Then so.
All right. Observations made for electrochemical cell. Okay. Now, First thing we saw that mass of zinc rod is decreasing. That means the mass of anodic rod is decreasing, right? Mass of anodic rod is decreasing. Next thing we saw that the concentration of metal ion at anode is increasing. Next we saw mass of cathodic rod is increasing and concentration of metal ion at cathode is decreasing. The last thing that we saw was electron flow from anode to cathode. Done, guys? Yes, no, please tell me.
Yes, sir.
Okay. Right, next, cell representation. This is quite important. It's a very small thing, but it is important. Okay, cell representation. Okay, so we represent the cell, and to remember this, you'll write A, B, and C. So we first of all write anode, whatever reaction is happening at anode, then we write for bridge, and then we write for cathode. Okay, so for example, if you remember the zinc one, in that we had zinc, which was getting converted to zinc 2 positive, and then we will write the bridge as this. If this is bridge, or it is representing the salt bridge. And in cathode, what was happening? The copper 2 plus was getting converted to copper solid, right? So this is the cell representation. That complete big thing that we made now, we can represent that big complete thing as this particular small cell. This is how we represent cell. Now this cell representation, it gives me an idea about the reaction that are happening at anode and the reaction that is happening at cathode. Okay, so what we are going to do, from reactions you can make the cell also, and from cell you can also make the complete cell reaction and the half cell reactions also. For example, if you have been given this cell, then we will write at anode what is happening. Zinc is going to give me zinc 2 positive, and with this 2 positive I understand that there will be 2 electrons, and then in cathode we are having copper 2 positive. See, this is copper to copper 2 positive, and zinc to zinc 2 positive as over. Plus it will eat 2 electrons in order to get copper. And we can write the complete cell reaction as 2 electron and 2 electron will get cancelled. Zinc plus copper 2 plus, it is going to give me zinc 2 plus copper. Okay, so you can write from the reactions, you can write the cell representation, and from the cell representation you can write the anode and cathode reaction, and from that anode and cathode reaction you can also write the cell reaction. Please write this, then we will do some questions. Done, guys? Done, everyone?
Done, sir.
Done. Okay. Write a question. Represent the galvanic cell. Represent the galvanic cell in which following reaction takes place. Okay, so for the E1, let me have, like, for example, nickel plus 2 Ag plus. This is going to give me nickel 2 positive plus Ag. Okay, so whenever you get this type of reaction, you will first of all see what is happening to nickel. Go from nickel to nickel 2 positive. Tell me what is happening? Oxidation or reduction? What is happening here? Oxidation reduction. Nickel का क्या हो रहा है? Oxidation और reduction? देख के बताइए ठीक से. निकल क्या कर रहा है? इलेक्ट्रॉन लूज कर रहा है, गेन कर रहा है? हमजा करेक्ट. लूज कर रहा है, तो ऑक्सीडेशन हो रहा है, रिडक्शन हो रहा है?
Oxidation.
ऑक्सीडेशन हो रहा है. इफ इट इज ऑक्सीडेशन देन इट विल बी एन एनोड या कैथोड? इट विल बी एन एनोड और कैथोड?
Anode.
Very good. It will be an anode. Okay, and this Ag to Ag, Ag positive to Ag. You don't have to worry about the coefficients. Okay, Ag positive to Ag. What is happening here? Reduction या oxidation Ag का? What is happening here, guys? Ag positive reduction is happening. Krishna, Atif, what happened? आ रहा है ना आप लोगों को?
Yes, sir.
Okay. पक्का कृष्णा?
Yes, sir.
Okay. So reduction, that means anode या cathode?
Cathode.
ठीक है. एटलीस्ट आप लोग इतना करके रखिएगा, है ना? कोई भी सवाल होगा इतना आप लोग को आना चाहिए कि निकल का क्या हो रहा है, मतलब किसी भी एक स्पीशीज का क्या हो रहा है. अब उसके बाद बहुत ही आसान है, आपको याद होना चाहिए. ए बी सी करते हैं हम लोग, राइट? एनोड में क्या हो रहा है? निकल से निकल 2 प्लस. सो विल राइट निकल 2 निकल 2 प्लस. ठीक है, ब्रिज दे दिया हमने यहाँ पे इस तरह से. कैथोड में क्या हो रहा है? कैथोड में Ag प्लस से Ag प्लस 2 Ag. दिस इज हाउ वी आर गोइंग टू राइट इट. ओके, so write next question. हाँ that's it, ये करना है बस आप, nothing else. हमसे I'm waiting for more answers. आप करके भेजिए आराम से.
Sir, should we send in WhatsApp?
हाँ, send in WhatsApp. हाँ, you have to send. Sorry, I did not say this. हम सवाल लेते हैं ना तो हमको चाहिए आंसर्स, ठीक है ना? I want to see how you have done this thing. Okay, Krishna. Correct. First one, B is correct. C correct. D is also fine. E is also fine. Okay, fine. You have to ignore the coefficients, Krishna, by the way. Okay, the stoichiometric coefficient, you have to ignore them.
Okay, sir.
Okay. Akshay, B is correct. C is also correct. D is also, yes, very good. Yeah, E is also fine, correct. Hiba, just waiting for you now. Hiba and Atif. Okay, Atif got disconnected. What happened, Hiba and Atif? Send the answers. The answer are over here. So here we have copper to copper 2 positive, bridge, Ag plus to Ag. Here we have Mg to Mg2 positive, bridge, copper 2 positive to copper. Here we'll have Fe2 positive to Fe3 positive. This is also oxidation because 2 plus 2, 3 plus it is being, right? Bridge, Ag plus to Ag, right? And then here we have Al to Al3 plus, bridge, copper 2 plus 2, copper. Okay. So these are the representation of different reactions that, I mean, these are different reactions which are happening in these cells that we have drawn. Okay. Now, let us write a point which is known as electrode potential. Right here, electrode potential. This is one of the very important concept. Right here, electrode potential. Right here, the potential difference between metal rod and surrounding electrolyte is called electrode potential. Okay, so as we have seen earlier, that if I have any metal which is dipped inside its own solution, if it is dipped inside its own solution, then what is going to happen? There are a few things which can happen, right? Either this metal is going to get converted into solution, or what will happen if this solution will eat up electron, it will get converted to metal. These are the only two things that is going to happen, right? Yes or no, please tell me, guys. You have seen this?
Yes, sir.
Okay. Now, once this happens, there will be some potential developed, because it will either get a positive charge or a negative charge. And if we have a difference in the charges, then it is going to lead to some kind of potential difference. And that potential difference is known as electrode potential. Okay. Now this electrode potential, it will also depend on the concentration here. Like if I have a very high concentration of, let us say, Mn plus ions, then the rod will not get converted to Mn plus, right? The Mn plus is going to get converted to that rod. So electrode potential will depend on the concentration of the electrolyte that we have. It will also depend on the temperature that we have, right? And it also depends on the pressure. Now, since electrode potential, it depends on these things, what did we do? We got a particular standardization of these electrode potential. Okay. And please write here, electrode potential depends on electrode potential depends on, number one, nature of metals, metal and its ion. Second, it depends on the concentration of ion in solution. And thirdly, it depends on the temperature. Okay, so these are the three things which it depends on. So what did we do? We standardized these things. So please write in remarks. If
So
electrode
please go.
potential. Please try to write things when I am writing, okay? Because these things I'm not explaining right now. No? Please write if electrode potential is calculated at is calculated at 1 atm pressure, comma, temperature of 25 degrees Celsius and 1 molar concentration and 1 molar concentration of electrolyte. Then it is called standard electrode potential. Standard electrode potential. Okay, but we know that the electrode potential, please don't write this, okay? Electrode potential, it can be either of oxidation, right? What can happen if I have metal which is giving me Mn positive, Mn positive and N electrons, right? So electrons are getting lost here. So that is going to give me, if I have some negative charge, that is also going to give me some kind of electrode potential. Or what can happen if the opposite reaction happens? That means if reduction happens, let us say, in which Mn positive, it eats an electron and it is going to give me metal. In that case, what is going to happen? We'll have negative electrode, not negative electrode potential, but we'll have negative charge, right? And it is going to give me some electrode potential. And here we're going to have positive charge. It is going to give me some electrode potential. Now we have to choose which of the potential we should choose as the standard electrode potential. It can either be standard oxidation or it can be reduction potential. Okay, we have to choose any one of them as the standard electrode potential. So what IUPAC did, please see here. All of you wrote the first point, yes or no? Please tell me. All of you wrote the first
Yes,
point?
sir.
Okay. Now what IUPAC did, let's see here what IUPAC did. If you see copper, now let us see Fe. Fe can be 2 positive also, Fe can be 3 positive also. But when I am going to reduce this Fe is going to take some electrons, this Fe is also going to take some electron, and it is getting converted to Fe only. If I talk about the solid, then Fe will get converted to Fe solid, yes or no? From any of these forms, Fe2 plus or Fe3 plus, correct? Yes or not?
Yes, sir.
Okay. But if I talk about the other case, this is what happening here. Here we are having reduction. In reduction, we know what is the product. So that from the product, we can determine the number of electrons also. But if I talk about oxidation, this Fe, it can either get converted, like it will depend on how many electrons it is getting. It will either get converted to Fe2 positive or it will get a Fe3 positive, right? This is happening in oxidation. So in oxidation, we cannot predict what is going to be prepared, right? Fe2 plus or Fe3 plus. But in reduction, we know that it is going to get converted into atom, that is Fe. That is why IUPAC what said, they said that the standard reduction potential will be regarded as the standard electrode potential. All of you got this? The reason also, yes or no? Please tell me. Because in reduction, we know what is the product going to be. Okay. In oxidation, we don't know. It can be this also, it can be that also. All of you got this? Yes or no? Please tell me.
Yes, sir.
Okay, fine. So right here, next point. According to IUPAC, standard reduction potential is regarded as standard electrode potential. Got it, Jason? Please tell me.
Yes, sir.
Okay. Now, I'll tell you something that you don't write now. Just explaining this now. See, if I have zinc giving me zinc 2 positive and 2 electrons. Okay, this is giving me zinc 2 positive and 2 electrons. And let us suppose that this is spontaneous. If this is spontaneous, then we can use this particular thing to generate some voltage of electricity. Correct? Yes or no? Please tell me, guys. I'm assuming this right now. Okay, I mean the assumption is sir, yeah, ये spontaneous है ये वाला reaction. What is this? This is a spontaneous reaction, and from this spontaneous reaction, if any reaction is spontaneous, and I have taken this specific case, but my thinking and my saying for you, my message for you is that if any reaction is spontaneous, that will give me some voltage that we can convert that spontaneous reaction, and we can convert that chemical energy to some voltage of electricity. Is that clear? Yes or no? Please tell me, guys. First thing.
Yes, sir.
Yes.
Okay, fine. So this will give me, let us say, some 5 volt. Let us assume 5 volt of energy. Now, what is going to happen, and what is happening here, by the way? Here in this case, we are having oxidation. Now, please remember that this oxidation has nothing to do with spontaneous, neither it has to do with anything with us voltage. Now, it is just a chance that we have taken a reaction which is oxidation, and we are supposing it is going to be spontaneous. Okay, now here we are having oxidation. Okay, and this particular reaction is going to give me 5 volt of energy. If I have the same reaction opposite, zinc 2 positive giving, sorry, eats 2 electron, and it gives me zinc metal, then obviously this reaction is going to be non-spontaneous, right? Yes or no? Correct?
Yes, sir.
Right? Because this is just the opposite. Spontaneous ka opposite kya hoga? Non-spontaneous. Now, the spontaneous reaction, it was giving us what? It was giving us the voltage of electricity. Now it requires, now what it does, it needs some voltage of electricity. That means it requires some energy for this reaction to happen. You have to give some energy. Who will give the energy? Who is going to give the energy? The human is going to give the energy. Correct? All of you, yes or no? Please tell me.
Yes, sir.
Right? Now, if we are going to give the energy, that means we are going to give how much energy? Minus 5 volts. Now, this minus sign says that we are giving energy, and 5 volts means that that is the magnitude of energy required in order to complete this reaction. All of you got this? Yes or no? Please tell me. Here, what is happening? Here, reduction is happening. Okay. So, if I see, I can say that standard oxidation potential, if it is equal to X volts, standard reduction potential will be equal to minus X volts. Yes or no? Please tell me, guys. And it is the reverse is also true. If we have been given SRP is equal to some X volts, then the SOP will be equal to minus of X volts. ये आप लोगों को समझ में आया कि नहीं आया? प्लीज बताइए हमें. आतिफ, अक्षय.
Yes, sir. Understood.
Yes, sir.
Understood? Atif, Hamza, Hiba, tell me, guys. Hiba, what about you?